So once your UE decodes SSB, it will decode your master information block. It will decode your system information block. We have seen the logs of system information block also, master information block also, everything. So this is what happened. It got SSB. In SSB, it got PSS, it got SSS, it got master information block through PBCH, through master information block, it got the information of PDCCH and then PDSCH, where we are getting system information block 1. Now, once we get the system information block 1, yesterday you know, uh, show you the RACH common config parameters, right? So UE has decoded lots of things, in the downlink. That means Gnode B is sending something that is your downlink, right? Now UE has to send something that is called as uplink, right? So now for the first time when UE, now why we are powering on UE, so as to use the the application to do the calling or use throughputs, data, whatever, right? So for that, DL synchronization has been done. That means this guy is synchronized with UE. Now this guy also has to be synchronized with this guy, right? That is called as uplink synchronization. Uplink synchronization, right? So for the first time when you want to have uplink synchronization, right? So at that point in time, UE wants to send out, a message called as RACH or physical RACH. Okay. At the initial time when you are powering on your UE, right? When you are powering on your UE, you are, first of all, just give me a second, guys. Yeah. Okay. So okay, so when you are powering on your UE, okay, uh, you are getting your downlink synchronization channels decoded as per, um, scanning is being done at the UE side, and then, you are decoding your SSB as per the band which you are getting, maybe N2, N78 or whatever. You have to scan it. And then, the first thing which you are sending in the uplink is called as, the reg, the physical reg. Okay. And why we are sending the reg, so as to get the uplink synchronization, because Gnode B is synchronized and UE is, UE also wants to be synchronized with UE in the uplink. Till now, DL synchronization has been done, right? So when you say, you are sending the reg, uplink synchronization, you want to know when I have to send. Again, when UE have to send anything, UE is your mobile, right? UE needs what? UE needs um, UE needs your uplink grant. Now, what is uplink grant? Uplink grant means the resource blocks. Okay, the resource blocks in the resource block wants to be used for for uplink, right? For uplink, you need resource blocks from whom? From Gnode B only, because Gnode B is the master. Gnode B is going to schedule it. But right now we didn't get anything, the grant from Gnode B, because we only have decoded SSB and master information block and system information block, right? So what will happen, once you got system information block, message 1, in which you will see, the RACH related parameters, which talks about, giving you the resources. Okay, those messages, those parameters are, available in SIB1. We call it as, branch, config index. Okay. Now, there is something called message 1 frequency start also. Okay, so this is message one frequency start parameter. Okay, something like that. So what is this? This both parameters will give you the time and frequency domain allocation. Okay, why? Because whenever I already told that whenever we need, you know, whenever we need to send out something, whether it is in downlink or uplink, right? From G node B to UE or from UE to G node B, we need to send it in both time and frequency domain location, right? We need both of them. Okay, so these parameter will tell us when to send the patch and where to send. Okay, this will give you the resource blocks. Okay, and this guy will give you system frame number and the slot. Okay, system frame number is nothing, it talks about your what, radio frames. Okay, this is your radio frames. Okay, in time domain we talks from the radio frame point of view. What is radio frame? We have 10 millisecond of, you know 10 millisecond of radio frame in 5G as well. Okay, it keeps on going. This is 110 millisecond, another 10 millisecond. you know we have given numbering to that, 0 1 till 1023. That means 0 to 1024. So this is how, this branch config index tells us message one frequency start will tells us the resource blocks, you know from where we are starting our resource block. Now in 4G there was something called, we are using 6 resource blocks for sending out our branch. Okay, but here why we are not saying that we are using 6 only? Because we have subcarrier spacing, you know that subcarrier spacing ranging for the red symbol, okay, for the patch. Okay, so in 4G, the subcarrier spacing was 1.25 kilohertz. So when we say 6 RBs, right? Let us say this is your 6 resource blocks. Okay, this is your 6 RBs. Okay, meant for sending out the range and frequency domain. So there was one parameter called patch frequency offset in 4G. Okay, so what, if you see that parameter in SIB2, now the difference between 4G and 5G SIB, where you are getting these parameter in 4G, we are getting these parameter in SIB2. In 5G, we are getting it in SIB1. Okay. Now the patch frequency offset says one resource block number, let's say 6. So that means, 6, 7, 8, 9, 10, and 11 are the resource blocks being used in 4G for sending the range. Okay, now this, you know 6 resource block is something like 6 into 12, right? In we are talking about in uplink, right? So PUSCH, right? Or PUCCH, whatever it is, right? In uplink direction, 6 into 12 subcarriers. There also in 4G it was 12 subcarriers. 6 into 12 is 72 subcarriers into 15 kilohertz, right? So somewhere we are getting 72 into 15. If you do, you are going to get around 1008, right? Just let me see, 72 into 15. Yeah, 1080 or something like that. Okay, this is, we are getting, in kilohertz. Okay, so this is, you are getting in kilohertz, you can convert it into megahertz, and then you can 1080 kilohertz, and this is what you are getting, right? Now this 6 resource blocks, okay, is being used, okay, for giving you subcarrier spacing for range. Now in uplink for PUCCH and PUSCH, right? we are using 15 kilohertz subcarrier spacing, even in 4G as well as in 5G for subcarrier spacing or numerology 0, right? But we don't need 15 kilohertz of subcarrier spacing to send it out our range, because we need to understand why what we are sending in range. We are sending one index number only. We call it as preambles. Okay, we are just sending the preambles over there. We have 64 preambles, okay, which we are sending in this message to G node B to tell the G node B that yes, this particular one UE wants to have the connectivity, and now G node B has to revert it back in the form of random access response, right? And that random access response includes what? It includes the uplink grant now. Okay. And then it includes the timing advance. Okay. It includes the temporary CRNTI. Okay. What is CRNTI? That is cell radio network temporary identifier itself. That too, it is giving TCRNTI. Now the question comes, why temporary? Okay, because there can be a case that two UEs are powering on, and why we are saying it as random access channel RACH, because it is picking up out of the 64 preambles randomly one preamble and sending it out. There can be a case that two UEs are picking same sequence ID of preamble. So to resolve that, there is something called, we are resolving the contention. And this type of RACH, we call it as contention based RACH. Okay, this is being done when you are in idle mode. But when you are in connected mode, you cannot play with the services, because let's say you are handing over from one cell to another cell, right? In that scenario, you cannot say that two UEs are handing over and both have taken, let's say, preamble sequence number 27, right? In that case, you need to, give UE a different, assignment of preamble sequence IDs. That type of, RACH is called as CFRA. Okay, so CBRA and CFRA. Now, as we are sending only sequence ID to G node B to tell G node B that provide me the grant to send out the third message that is called as RRC connection request, right? So for that grant, I am sending it out the first message, and I am getting the uplink grant, timing advance, and TCR NTI, right? So for that reason, I'm sending this out, right? So that sequence, I don't need 15 kilohertz of subcarrier spacing. For that reason, I am in 4G using a predefined 1.25 kilohertz of subcarrier spacing, which will give me around 839 plus some, 25 also, some 860, 4 or something like that subcarriers. Okay, in the 6 resource blocks. Okay, so this 839, we call it as root sequence indexes. Okay, so this is what we call it as root sequence indexes. But in 5G, this is not constrained towards 6 RBs. Okay, because I can explain it. Just give me a second. Let me open my red slides. Just 1 second. Yeah, over here, if I Yeah, so this is the one which, which talks about, 4G 6 RBs breadth signal structure. So if you see, this is your 6 RBs being used in uplink subframe, which is 1.08 megahertz. Okay, so coming about that 72 into 15, 1080 or 1008, whatever it is coming. Okay, and we are getting, this 1.08 separated by 1.1 subcarrier of Praj preamble is 1.25 kilohertz, whereas one subcarrier of uplink subframe is 15 kilohertz. Okay, so that means we don't need 15 kilohertz of subcarrier spacing, because we are only sending a preamble sequence ID in my message one, right? So you see 839 subcarriers, which is called as root sequence indexes also, and 13 this side, 12 this side, or something like 830 plus 25 864 or something like that we are getting in 1.08. This is for the 4G. But when we talk from 5G point of view, you know um, this is not the case. Okay, because you can see we have different subcarrier spacings. Okay, so if you see 839 1.25 kilohertz for random access, the subcarrier spacing, we are getting 6 PRBs. Okay, but when you say for 30 kilohertz, it is 3 PRBs. 839, 5 kilohertz of subcarrier spacing you can give also for 15 kilohertz of you know PUSCH is 15 kilohertz, and this is numerology 0 only, but I am using 5 kilohertz of subcarrier spacing. We are getting 24 PRBs to be used over there. And there is something called, long sequence and short sequence. Okay, L is equals to 139 and L is equals to 839. These are, the root sequences, indexes being used. And, this is what, how, we are using, and you can see the use cases also for that. Format 0, for the preambles, we have different formats. The 839 root sequence indexes with 1.25 kilohertz of subcarrier spacing. We are using it for LT, large cell, weak coverage cell, high speed. We can discuss this in upcoming session. But today we just discussed